Horizontal motion problems. I'll go ahead and let you read the problem to yourself. Go ahead and pause the video and read the problem. Okay, so something to notice. One, the turtle is moving at 5 feet per minute, and the snail is moving at 3 feet per minute, okay? So those are your numbers that's going to go with T. Or I should say X, because it does say let X represent the number of minutes, okay, that they travel. So and Y is going to represent the distance from the oak tree. Now the turtle, he is at the oak tree, okay? So he is at the oak tree. The oak tree will represent 0, 0. And the snail is 150 feet away. So we want to write the equations for both, okay? So the turtle is moving away from the oak tree. So at 0, he is moving at 5 feet per minute, 5x. So actually this, we'll just call this y sub 1 for the turtle. He's moving away from the oak tree. So his distance from the oak tree is getting bigger as time increases. So we have a direct variation here. Here, the snail starts 150 feet from the oak tree, so that's how far he is from the oak tree, and his distance is decreasing at 3 feet per minute. He's getting closer to the oak tree. So turtle's going away, snail's getting closer. We'll call that y sub 2. It says graph the two functions and determine when the two animals will meet. Well, basically, we have here is a system of equations, okay? So we're just graphing a system of equations here. So let's go ahead and do that. Okay, so one of the ways we could do this is we could set up a table starting off with time is 0. Okay, plugging it in for our turtle. In 0 seconds, okay, the turtle has gone 0 feet. In 1 second, the turtle has gone 5 feet. 2 seconds, 10 feet. And in minutes, I don't mean to say seconds, in X minutes, the turtle has gone 5x feet. Now the snail, 0 minutes, if I plug 0 into the equation, the snail has gone, well, the snail is 150 feet from the tree. And I probably should have said that over here. 0 feet from the tree, 5 feet from the tree, 10 feet from the tree, and so on. In 1 minute, the snail has gone 147, 3 feet per minute. Okay, so we could continue on with this and see if our tables would eventually be the same. The y's, where the distances would be the same, and that would be where the two intersect. So what we're going to go ahead and do here is we're going to use our calculator, and we're going to do the graph on our calculator. Okay, so plugging the two equations in to y equals, and then second, calculate, intersect. And by the way, I did set up a window that works for this. So we're in the first quadrant, and we just press enter, enter, enter. And the point of intersection here is 18.75, 93.75. Okay, so setting up my scale, and I should have used a pencil because it's not good enough. Let's put it that way. We found out that the intersection point using our calculator is at 18.75, comma 93.75. So I plotted that point. I went by 10s, I went by 25s, I went to 18.75 up to about 93. Well, I'll sketch it in the best I can here. Here we have the tortoise. I should get a ruler, but I don't have a lot of time, so I'm just going to sketch it in here. Okay, notice the tortoise is going at 5 feet per minute, and the snail, okay, pretend like that's a straight line, would you? Sorry about that. I should have used a pencil because my scale's messed up here. Notice how this is smaller than this, and they should be a straight line, straight down to about 50. Anyway, there's your point of intersection. It says, how long will it take the two animals to start to switch places? Okay, so we set 5x. We want the tortoise to be at 150 meters from the tree. So it's going to take the tortoise 30 minutes. We want the snail to be where the tortoise was, so we set 150 minus 3x. We want it to be 0 feet from the tree. So solving that, we get x equals 50 minutes. And it makes sense. Tortoise is going faster, takes less time. Snail's going slower, takes less time. Turn the page. Okay, so we're going to go ahead and put these in as parametric. We need to change the calculator mode. So go ahead and go into your mode. Okay, make sure you are set to parametrics. And we have a race between two horizontally moving targets. So make sure you click on simultaneous so that we can see them both racing at the same time. Okay, so x sub 1 is going to be our turtle's horizontal motion. Turtle's horizontal motion. Y sub 1 will be, now this is going to be where like the lane in which the turtle is going to run in across the screen. So let's put the turtle in lane 2. X sub 2 is going to be the horizontal motion of the snail. And let's put the snail in lane 3. That's kind of like the position on the screen. So the snail will be on top, the turtle will be on the bottom. And let's go ahead, we set up our graph going from 0 to 50 minutes. And t-step, now we could range it from say 0.1 to 0.5. And let's take a look at what 0.1 does. And as we change it to 0.5, let's see what happens to the race. X minimum, so starting at 0 feet, maximum 150 feet, horizontal distance from the tree. Okay, you know, this is just to make sure that we have plenty of room to see the race. So we put them in lanes 2 and 3. So let's go from 0 to 5. Make the racetrack large enough. And let's go ahead, it says press graph and watch the race. Well, I've already set it all up. I plugged that in. Okay, I set up the window, and actually I had already put it to 0.4, so let's put it at 0.1 and let's graph it. By the way, back over here, so that you actually can see them moving, if you arrow to the left, you press enter until you get that symbol, okay, on both of them. Make sure you have that symbol going on. Alright, so press graph, and there they go. And they're off at a very tremendously, take forever, slow speed. So, second mode doesn't do anything, so press on to stop it. Okay, second mode, we're going to quit out of there. Go ahead and go into the window, and let's change this to 0.5. Now graph it. Much better, much better. So we can see that the tortoise on the left and the snail on the right, the tortoise is getting away from the tree, the snail is going towards the tree. And we can see, the turtle won the race. And the race was to see if they could get to each other's original position the quickest. Let's graph it. And there's your graph. There's your turtle going to the right. There's your snail going to the left. Alright, turn the page. Okay, well that looks like that's all the notes. So the color for today is green. I'll see you guys tomorrow in class.